Today we are going to shift our attention to looking at the nonmetals on the periodic table and spend just a couple moments looking at the metalloids as well. And we want to look at the properties and the characteristics of these groups. So just to point out, if you remember, last week we were talking about the metals. Those were represented by all of the pink elements on this periodic table. And now we're going to look at the nonmetals, which are going to be characterized by blue. And then we're also going to look at the metalloids, which will be characterized by green on the periodic table. So notice how they are organized. For the most part, you will see that all of the nonmetals are over here on the right-hand side of your periodic table. There is one exception. Hydrogen is its own little category, but it is a nonmetal, and it's stuck over here on the left by itself. And then you will also notice that you have the green metalloids that are sort of here in the center between the metals and the nonmetals. So our periodic table is broken into three groups. The pink are the metals, the green are the metalloids, and then the blue are the metals. And that's what we're going to be looking at today. So let's first look at, the properties and what are the characteristics of nonmetals. A nonmetal, is an element that lacks most of the properties of a metal. That makes sense. It's not a metal, it's a nonmetal, so it's going to lack the properties of metals. Again, they are mostly found on the right-hand side of the periodic table, the exception being hydrogen. And in general, most nonmetals are poor conductors of electric and heat, and they tend to be dull and brittle. So they're the opposite of the metals. Metals were shiny for the most part, they had luster, and they were good conductors of heat and electricity. These are not. We will also find that many nonmetals are gases at room temperature as well. When it talks about the chemical properties of nonmetals, it's basically just talking about their ability to share or lose or gain electrons and combine with other nonmetals in order to form compounds. So many nonmetals can form compounds with other nonmetals. They do this by gaining or sharing electrons when they react with other atoms. So this chart that you filled in yesterday was basically just a comparison of the properties between metals from last lesson and the nonmetals in this lesson. Looking at this chart, they have sort of organized the nonmetals into their groups or into their families. We just talked a moment about how hydrogen is in its own little group over there in group number 1 or family number 1. We will see later that the noble gases have that special name, and they are found in group number 18 in the far right-hand side of your periodic table. But groups 14 through 17 are named basically just from the element that exists at the top of that group or the top of that family in the periodic table. So group number 14 at the top of the periodic table is carbon, so it's called the carbon family. Group number 15, nitrogen is at the top, it's called the nitrogen family, and so on. Oxygen is 16, and then we call the group 17 the halogen family. We're going to look at each one of these individually and talk about some of their characteristics. So the first group that we want to look at, or the first family, is the nitrogen family, which again is group number 15. Whoops. Group number 15 on the periodic table. Nitrogen is one of those atoms that only exists when it's bonded together with another nitrogen atom. We call that a diatomic molecule, which means it's made up of two atoms. So because it's combined like that, that makes it not very reactive. So in nature, nitrogen is always going to exist as two nitrogen atoms bonded together. Phosphorus is another nonmetal that is in the nitrogen family. It is a little more reactive than nitrogen and is almost always found in compounds. So in this green box over here, I wanted you to shade in the nonmetals in group 15 on the periodic table. So that should have been these top two, nitrogen and phosphorus would have been the top two. Moving over a family, moving over a group, brings us to the oxygen family, which is group 16. Group 16 is the oxygen family. It contains three nonmetals: oxygen, sulfur, and selenium. So when you were shading in this box, you should have shaded in the top three. And you'll notice as you did these that there is a pattern beginning to form. The next to the last group, or the next to the last family, is what we call the halogens. The halogens, which means salt forming, is a very reactive group of elements that combine with other elements to form lots of different compounds. One of the most reactive would be fluorine. So fluorine is the most reactive of all the elements. So reactive that it actually reacts with almost every other known substance, including water. However, even though the halogen elements are very dangerous, many of the compounds are quite useful. For example, the fluorine, the fluoride that is in your toothpaste actually comes from one of these. So if you were to shade in the nonmetals in the halogen family, it would have been the first four in that group. The noble gases. They are called noble because they exist on their own and they don't like to combine with anything else. They are very, very stable. When we talk later about electrons and their shells, we'll talk about what that means, but they don't react with other things. So they are known as the noble gases. They do not ordinarily form compounds because they don't typically lose, gain, or share their electrons. So they're very non-reactive. And in your last column, that's what we call the noble gases. And technically, the noble gases would be all of these, except for this very last one, doesn't always get considered a noble gas because it is synthesized or it is man-made. And then lastly, we want to mention hydrogen, because it's just this little character that's over all by itself in the upper left-hand corner of our periodic table. It is one of, it's sort of the simplest form, simplest atoms, and its properties, its chemical properties, are very different from those of any of the other elements. So it can't really be grouped into any family. However, it's important to know that, hydrogen makes up more than 90% of all the atoms in the universe. 90% of the atoms in the universe are hydrogen. So massive amounts of hydrogen actually there. But hydrogen makes up only 1% of the mass of Earth's crust. Most hydrogen is combined with oxygen in water. So it's rarely found in its pure form. And for the metalloids, these are those elements that exist In the green on your periodic table that we've been looking at, in your book, they're sort of a shaded yellowish green color. So the metalloids have some properties of metals and some properties of non-metals. All metalloids are going to be solids at room temperature, and they're generally brittle, hard, and somewhat reactive, not overly reactive. One of the most useful properties of metalloids is their ability to conduct electric current. If you've known much about computers, you are familiar with semiconductors, which are substances that can conduct electric current under some conditions, but not under other conditions. So computer chips, transistors, lasers are examples of semiconductors, and these are the elements that are used to make those semiconductors. They're also used in solar cells. All right, tomorrow we will do a little activity with periodic table on page 104, 105, and go back through now and answer any of the in-text questions or fill in any of the tables, pages 97 through 103 that you may not have gotten to yesterday or make a little bit more sense now that we have gone through the lesson. Thanks, have a great day, and see you soon.